Welcome to the first tutorial of the Redback flange FLG application. The purpose of this application is to do calculations for piping and equipment flanges as per the EN 1591-1. Let's start entering with the first piping flange. First I will give the project a reasonable name. You can enter the description and the company and location for this particular project as you need. We enter the flange assembly here. Give it a specific number, which is usually something like an abbreviation of the pipe class, and a reference to the pipe size, which is in this case an 8-inch 150 pound flange with a spiral wound gasket. I leave the revision as it is, the date of today. My name is Rutger Botemans, and I add a note here just to keep reference to all the changes I've made. And this is for the tutorial only. We enter the flange material and dimensions on this tab. Here we enter the material, which is of course a forging A105. I will use the dimensions from the database, which can be different standards: weld neck, 150 pound raised face. I will use here the 8-inch selected. I'm informed that the normal bolt diameter is 3/4 of an inch. And you see all the data is set also. With the details it has been set, and the drawing is updated over here. I will tell the application that flange 2 is equal, and it will draw the second flange. We select the gasket on the gasket tab. We select a tested spiral wound gasket, like this for example. We will have to give the dimension. We will select the dimensions spiral wound 150 of the B16.20, and the DN200 is the same as an 8-inch spiral wound gasket. You can see the drawing here with the various dimensions. We select the material for the bolt, nut and the washers. The material of the bolt, which is of course bolting material. In this case it is low alloy. We will select the B7 bolt, smaller than 64 millimeters. We will select the material for the nut, which is a 94/7 grade. The number of bolts have already been set by selecting the flange. I have to select the size, which is an ASME B1.1 UNC thread, because it is smaller than 1 inch. I'll select the bolt over here. You can see that the bolt is drawn here. As a default it takes stud bolts and a torque wrench as being the appliance to torque the bolt. We add the shell to the flange, which gives some additional stiffness to the flange assembly. We select the material. It is a pipe, and it will be carbon steel, and I will select it from the ASME 106 grade B. The material is set. I will select the pipe from a pipe standard, a standard schedule, and I will select the 8-inch pipe. Here we enter the load cases. Please note that the 0 load case is always the assembly, 1 is a test load case, and the subsequent conditions are the design conditions. So we enter the first one. There will be no pressure during assembly. All the temperatures are set During testing we will have a pressure of 2.5 Pascal. For example, we have 20 degrees Celsius again. We will add a design condition, which for example would be 1.77 megapascal at 100 degrees, and we can add another one, and this will 1.02 at 300 degrees. I refresh the material properties by clicking this button. This will set all these properties calculated from the database in the proper format. This is done manually because you will be able to change or update these factors if necessary by hand. And we can do the first calculation. I will show you the summary report. I click calculate, and we have here the first valid calculation. And here we can see that the minimum required for the leak tightness is 3.57 kilonewtons. If I increase with the gasket the leakage rate to a lower leakage rate, and we do again, remember the 357, we do calculate, you will see for a higher leakage rate you will need a higher bolt load. This was the first tutorial on the flange FLG application from Redback. Thank you for watching, and until next time.